Hi, and welcome to this week's online discussion. Since you guys are having a midterm this week, this discussion will be dedicated to reviewing for your midterm. And the professor has indicated to me that the section 12.5 will be most relevant to your midterm. So today I'm just going to do a bunch of problems from 12.5 that are taken from the recommended homework list. There are a lot more in that list, and I recommend you to check them out. So for this first problem, we want to find the equation of the plane. Let's call this P, containing the point 314 in the line of intersection L of the planes x plus 2y plus 3z equal 1 and 2x minus y plus z equals negative 3. So, what's the idea of finding a plane? So we need to find the normal. We need to find the normal vector n of my plane P. And if I can do that, I can use the fact that 314 lies on my plane P to obtain equation that expresses P. So how do I find the normal? So notice that the normal is the unique direction vector that is perpendicular to everything on the plane. Right. And we know that a plane is spanned by two independent directions. So when I say independent directions, I mean directions that are not parallel to each other. So they're not scalar multiples of each other. So what I need to find, what I need is two independent directions that are on P. So how can I find these two directions? So first notice that since L is on P, the direction of L is going to be on P. So let's first solve for L. So L is defined as the intersection of my two planes, which is x plus 2y plus 3z equals 1, and the plane 2x minus y plus z is negative 3. And since my L lies on both these planes, my direction of L must be perpendicular to both their normals. Right? And we know the cross products, if inputting two independent vectors, gives me the unique direction vector that is perpendicular to both. So I can compute the cross product of the normals of the two planes that intersect. So L can be written as V naught plus T times my direction vector, which is going to be the normal of the first plane, which is 1, 2, 3, cross the normal of the second plane, 2, negative 1, 1. So it's going to be V naught plus T times 5, 5, negative 5. I'm just skipping over the calculations. You can, because I don't want to waste time on these things I can do on your own. So here I have my direction vector 5, 5, negative 5. And we know that lies on my plane P. Great, so we have one direction from P. I need a second independent direction of P. So how can I find that? I just need 2 points on my plane P that are not on my line here. And I can just subtract these 2 points to get a vector that is going to be another independent direction for my plane P. So I need another point that is on P. So how can I get that? So notice that my line L is V naught plus T times 5, 5, negative 5. And so no matter which V naught I choose, so for all V naught plus T times 5, 5, negative 5 equals A, B, 0, always have a solution. So it means no matter which V0 it happens to be, I can always find a T such that my last coordinate is 0. Right? So it means that my line must intersect the plane z equals 0, right? And if my line intersects my plane z equals 0, then my two planes here are my two planes. Let's call this P1 and P2. Must intersect z equals 0. Because my line L lies on both these planes. So let's set z equals 0, and the equation for the two planes P1 and P2 reduces to this: x plus 2y equals 1, and 2x minus y equal negative 3. And solving gives that x is negative 1 and y is 1. So this point here that is negative 1, 1, 0 also lie on my line. And so it also lies on my plane P. Great, so now I have this point is on P, and I'm given that my 314 is also in P. So I have another 2 points that lie on P, so I can compute their difference to get a direction. So 314 minus -110, which is equal to 404, is a direction on P. Notice that this direction is indeed independent to my original direction that I calculated, which is 5, 5, -5 for the line. Great, so we now have two independent directions for the plane, so we can get the normal. So the normal n of my plane P is going to be n equals 5, 5, -5 cross 404. This is giving 20, -40, and 20, -20. But since this is direction, I can scale it by any real number, so I can scale it to be just 1, -2, 1, -1. So this is going to be my normal for my plane. But I also know that 314 lies in my plane. So the equation for my plane is just going to be x, which is 1 times x minus 3 plus -2 y minus 1 plus -1 z minus 4 equals 0. And we are done here.